interwebs, welcome to Let's Fix Computers. I've got a Lenovo here. This is one of those. I don't know what this is because all the labels are missing from the bottom. Okay, do we know anything about this? No. I've got a Lenovo here and it has a broken DC jack. If you have a look in there, as you can see, the inside of the DC jack is completely snapped off. So this guy needs a new DC jack. And we have a replacement DC jack. Now, Lenovo are one of the final holdouts for brands that that solder the DC jack directly to the motherboard. It's very annoying. They still do this on modern Lenovo laptops. Pretty much every other manufacturer at this point knows that this is a terrible idea. And you should always put your DC jack on a little fly cable because these things get messed up. It's just the way it works. There's a lot of mechanical stress that goes into these. Customers mistreat these. Like at least more than half of the customers who walk into my shop will walk into my shop with a laptop that has the cord just wrapped around it. Now we can sit here and we can say, oh, that's stupid, they're stupid. It doesn't matter. That's what they do with it. So it's fairly safe to say that this guy is probably going to get damaged at some point in his lifetime. And if it's on a little fly lead with a plug, it's a 2-minute job to replace. When it's soldered onto the board, now we have to fully disassemble the laptop and start doing board repair work to it. It's a pain in the ass. Anyway, rant aside, let's start taking this laptop apart. If this was on a little fly lead, I wouldn't even bother making a video about it, but that's where we are now. And I tell you what isn't where we are. It's there it is. Right, screwdriver, let's go. Right, all the screws are removed. Let's pull out the DVD drive. There are no screws under there. Sometimes there are. You should always check. Now, what's coming off? I'll use my prying tool just to have a quick peek now. And we want to see if the keyboard is going to, if the top case is going to come off or the bottom case is going to come off. It could be either. Okay, and the bottom case is going to come off. So as we peek in there, you can see that all the actual interior of the laptop is attached to the top. So I'll lay this back down again. And now I should just be able to just wrestle this off. There we go. Okay, right. Got a tiny little M.2 there. Very well. That is not awful, all things considered. 4 gigs of RAM. Have we got any soldered on RAM down there? Yeah, we've got some soldered on RAM down the bottom as well. So that's going to be 8 gigs total. Fine. Not a massive fan of this kind of design. I wonder if the soldered on RAM plus the module can do dual channel mode. That would be interesting. I'm not going to find out. That's outside the scope of this video, but Right, let's start stripping. So we'll disconnect the battery. There we go. So the battery needs to come out. The fan needs to come off. And then I think we should be able to take the motherboard out. Let's keep undoing things. So there are 2 screws down here on either side of the DC jack, and that stops the entire jack from getting ripped off, and I think it does generally reduce a very common fault you used to see is on soldered on DC jacks is the center pin, which comes out the back here. The center pin would fracture at the back. That used to be quite a common issue. And I believe having these two screws here does give it enough rigidity that that no longer occurs. But this doesn't change the fact that the entire middle of the jack can still get broken off, and you still need to replace the whole thing. So it doesn't really solve any issues. However, it's not too difficult to get the board out. Display cable, speakers. Right, that's our motherboard removed, so we're ready to start working on this. Oh wow, that's proper broken back there. Oh, we've had liquid damage in here as well. Uh-oh. Okay, well, to my knowledge, this thing starts and runs, so hopefully that doesn't cause an issue. Let me give you a close-up of that. So you can see the broken back end of the DC jack here, but also I started spotting that staining going, what the hell's going on with that? And then you can see we've got corrosion back here. So at some point liquid has come in through the DC jack and gone across things. It may have spread further, but it's most noticeable here because this is all high power stuff. And the higher power, the higher energy circuits, this is what will create more corrosion, because the corrosion is caused not by the stuff, I mean, there is some literal rust there, but what causes this corrosion is when you have electricity flowing through water, you get electrolysis. And what that does is the electricity splits the molecules of the water into hydrogen and whatever the other thing is. And you get these chalky deposits left behind as a byproduct of that as the surfaces break down. So that is what actually causes the damage. And this is one of the reasons why it's entirely safe to quite literally wash a circuit board and then power it on as long as it's dried properly. Because it's not the liquid that does the damage, it's this that actually does the damage. So to my knowledge though, this board works. I will clean this up while I'm working on it and we'll hope for the best. And with a bit of luck, this isn't something that I'll have to get involved with. I really hope not anyway. So I've now clamped the board up in my vise here. We've got some rubber bits to protect the board, and I've only loosely clamped this. It's enough so that it holds in there, but you can see I've got a little bit of movement there. So it's enough to hold the board in place without damaging the board. And we're mostly clamping on the other connectors. So we've got all of those anchors holding everything in place. And we're now going to come in with my hot air at full tilt, and we're going to take this guy out. So I'm going to heat from the back, and we're going to flow each of the joints up, and then when it starts flowing, we'll just whip that out with the pliers. There it goes. This is quite a violent removal for the old connector, but we don't care about the old connector, so. Now next I need to clear the holes so I can put the new jack in place. There's various ways of doing this. I do actually have a proper desoldering gun that is specifically designed for clearing holes like this. However, these ones are very close to being clear, so I'm just going to show another method that you can use, where I'm going to use this LED leg just to clear the holes. You can also use a wooden toothpick, although I've never seen a wooden toothpick that's actually thin enough to get into holes like this. Loads of people tell me they use toothpicks, and I'm like, I don't know where you're getting such small toothpicks from. Although maybe there are specific toothpicks specifically for soldering. Who knows? Either way, I'm going to quickly try this LED method, and if it starts fighting me, I'm just going to warm up my desoldering gun, which is the sensible way of doing it. So let's, I've applied some flux, and I'm just going to get in there and make that flow. And I've got everything at a really awkward angle for myself, which is not good. I might change that up in a minute as well. Right, let's try this out. So I'm going to try and touch up from the back. and then just push that LED through and use the heat in it to clear the hole. I might have to apply some additional solder in order to get things moving though. See, this is why the wooden toothpick is better, because the solder doesn't stick to it. This isn't going particularly well, but also I feel like this is kind of representative of how a person can struggle with this method. If you've got this down to a fine art, it can really work. There we go, that's sort of done it. We've got a hole there. That'd be good enough for a through-hole component, but I'm going to be honest, I'm going to get my desoldering gun out because I know that's going to zap these holes and they'll be completely clear. So let's get the desoldering gun heated up. When it's possible, I do like to try and show multiple methods of doing things, preferably one method with fancy tools and one method without the fancy tools, because it means that for people who don't have fancy tools, I'm showing you an accessible method. And for people who are like, I want to buy the fancy tools, but what do I get? I'm demonstrating what the fancy tools would do as well. So my desoldering gun is not terribly fancy. It's this cheap Chinese one. I recently put a new heating element in this one. But other than blowing a heating element, it's done me proud so far. So let's see what this can do with these holes. So I'm going to add in some fresh solder. And that's just to lower the melting point of the solder in the hole and just get everything moving. Right, we didn't quite get that first try. It's going to need another one. This is very difficult to do under a camera, by the way. That's my excuse. Oh, I slipped at the last minute. Damn it. Come on, third time's the charm. There we go. That's a clean one. Look at that. That's what we want to see. A classic mistake I always make with this guy is I do too smaller bursts. You want to keep it going for just a bit longer than you think you do, just to make sure it really gets everything. If you let go slightly too soon, it won't clear. That's another one. That guy is already clear, so I'm going to leave him alone. Not quite. This would probably be easier with a smaller nozzle on my desoldering gun. However, this is a lot less painful than using wick or anything like that. I've tried the other methods. Wick is horrible for doing this. It's doable, it's just horrible. There we go. There's our center one done. Oh, you know what? That's probably good enough. One hole that's not quite there is usually close enough. If you've got all the holes that aren't quite there, you'll have problems. Always remember to switch off your desoldering gun as soon as you stop using it, because that's how it's really easy to accidentally leave it on overnight, which is how I destroyed my previous heating element. Right, let's see if this is going to go in for me. Yep, so that hole that's not quite clear is giving me some problems, but I can probably scrape through that. Like that. There we go. There we go. And that's now dead flat on the board. Lovely. If these holes weren't clear, we'd have to try and heat this and put it in at the same time, which will damage the connector. And if we were trying to clear those holes manually and all of them were a little bit blocked, you'd be fighting it and it being slightly crooked and you'd be trying to step it in, and anyone who's tried to put these in manually, well, I tell you, back in the very early videos of this channel, there are still videos that exist of me trying to do this with a soldering iron, just soldering iron heroing, cutting the old one out and getting the old one in and stepping in, and it's not quite flat, and I'm just like, oh my god, and come a long way. Come a long way. All right, so now I'm just going to put this flat on the desk and solder it. I'll put some extra flux on all of these just to help the solder flow better. Since it's likely to come up as well, the flux that I'm using right now is fake Amtex. However, I've recently acquired genuine Amtex flux, and I'm planning on doing a video where I actually do some comparisons between the fake stuff and the genuine stuff, just to see if I can actually tell the difference. Theoretically, it should be night and day different, but I'm interested to know if a casual solderer like myself can tell the difference, or if you actually need to be an expert for it to actually matter. Right, let's solder one hole. Oh, okay, all of the solder could go to the wrong side of the iron, that's also fine. There we go. Right, now I'm going to just check that we're flat on the board. Yeah, see, that's lifted ever so slightly there. So I'm going to press the connector back in as I reflow that one hole. There we go. Ow. And now we can do the other anchors. Come on, I'm not getting heat into the actual leg. There we go. And I'm just holding there for a moment, just to make sure that all of the heat that's in the solder flows into the leg. Just reflow that, just for good measure. And the little anchors up the front. I'm probably going to do these from the top, because there's not a lot to get hold of down here. And I'm turning the board around just so I can get a good angle on it. Make the board work for you. That's a good one. That was a good solder. That's how it should go. All of that solder went straight down into that hole, which is what we want. And now what I'm doing is I'm just filling these holes up with solder. So we can see there's a nice pool of solder all the way around. And that just gives these things the best chance of just not letting go. Whoops, we've got some solder on top there. I'll just see if I can pull some of that out. That's good enough. There's just a screw going down on top of that. It'll be okay. And we'll do the back just for good measure. There we go. Right, and that guy's all on. So now I'll just spritz this all down with alcohol and tidy up the board, and I'll show you what the result looks like. There we go, that looks a bit neater now. We've got some big old blobs of solder sticking up there, but I'm okay with that. I like this isn't like a stalagmite of solder, that's just where there's a lot of solder in that anchor hole. But that's good, that's more material as far as I'm concerned, which means there's more to bond onto the pins. So, and from the top, that looks nice and tidy. And as you can see, every hole is full of solder, so we know that none of those are going to let go. Excellent. And hopefully, if we're lucky, there's no issues with any of this circuitry back here. I'm a bit worried about that. Some of these caps don't look too happy, but I'm fairly certain that this is fine. It doesn't look great, but I'm fairly certain it's all going to work. Let's plug it in and find out. I've lost the laptop. Where did it go? That's back there. Right, I've put in enough for the board to power up. I'm going to very carefully open the screen, supporting it right next to the hinges, because with the back cover off, those hinges will just snap off if I try and open it. But I just want to get a power on post to confirm that everything is okay. Right, I've plugged it in. And we have a flashing indicator. Ooh. I think that was... Okay, that's probably flashing because the battery isn't connected. It just beeped at me very loudly. Okay, there we go. Cmos... Okay, that is system Cmos checksum bad. The BIOS is reset. However, it has powered up. It has powered from the thing. Let's enter setup. There we go. Now we've got a nice big full screen display. I'm now just going to wiggle the power cord to check if we have a bad connection. If the laptop cuts out, that means it lost power and we might have a bad connection here. However, I'm giving this abuse as much as I dare for a soldered on jack, and that seems to be completely fine. And if I actually pull it out, it powers off immediately. Good. That's a fix. Let's reassemble. I'm now going to waffle while I put these screws in. So my thoughts on this is a repair that I thought was obsolete. I have a suspicion that around the time when I got that desoldering gun, I have a suspicion that I said words to the effect of, as useful as this thing is, I have a suspicion that the time of needing it has actually passed, because no one solders DC jacks directly onto the motherboard anymore. And I had a suspicion, I was fairly certain that this repair was a thing of the past. However, thank you to Lenovo for keeping it to be necessary. So again, if you're into repair, this is another example of why, even if you're not planning on doing intricate board repair, it's still worth learning soldering, and it's worth buying soldering equipment, because repairs like this doesn't require you to learn how to read schematics and learn how to diagnose bad power supplies and things like that. This is just something that requires you to be handy with soldering equipment. So it demonstrates the need to have these skills, even if you're not planning on going into super detail. And it's a repair that shouldn't be necessary. In this day and age, this should have been a 30-second job of changing the DC jack out by unplugging it. But there we are. Right, I think that is everything. Let's put the back cover back on. If you want to, you can go through and replace thermal paste and stuff like that. This laptop is fairly new. There's hardly any dust here. I shall remove what little there is. The thermal paste is going to be fine under there. And the Cmos battery, you know what? Let's check that, because if I don't check these things, everyone will get angry at me in the comments. So we'll check it. I would bet money that it will be fine. However, it's worth noting that occasionally I have seen bad Cmos batteries on fairly modern laptops. Usually when that happens, it's because there was actually a fault with the battery, and there will usually be an accompanying fault with the laptop. But in this instance, I'm not holding my breath, if I'm honest. There we go. There's 3.17. It's minus 3.17 because the probes are the wrong way around, but that battery is basically full. Anything that is 3 volts or less in circuit is no good. And if you're at like 3.0 something, you might want to consider replacing it anyway while you're at it. However, 3.17, that's A-OK. No problems at all. There we go. There's our charge light. Now the battery's all connected as well. There we go. That's one fixed laptop. So thanks for tuning in, everyone. I hope you guys found that interesting. A repair that shouldn't be necessary, but just still is, because thanks, Lenovo. P.S. Lenovo, please start using fly leads. This is not a job that should require this level of work. Thank you all. Bye for now.